Hey everyone, and welcome to This Explainer. Today, we're exploring the foundations of computer systems and data processing mastery. We're going to trace the absolutely fascinating journey of how raw, scattered facts get systematically transformed into the powerful information that literally runs our modern world. Let's get right into it. All right, here is our roadmap for today. We'll be hitting 5 key areas. First, decoding data and information. Second, the data processing journey. Third, the evolution of processing methods. Fourth, the anatomy of a computer system. And finally, the real-world impact. So we're basically scaling up from the tiniest microdata points all the way to massive global consequences. Kicking things off with Section 1, decoding data and information, moving from raw facts to knowledge. To really get a grip on our digital world, we have to start with the absolute basics. So what actually is a computer? Well, at its core, it's basically a highly specialized engine. It's a machine built for one primary job, processing data. It takes inputs in, stores them, uses a central processing unit to crunch the numbers, and then spits out meaningful, actionable outputs. That's the foundation of everything we're talking about today. Now, we honestly tend to use the words data and information interchangeably, but they are totally different. Data is, well, actually think of data as completely raw facts. It's unstructured. It's just a random name, an age, a stray text, or a raw audio clip. Information, on the other hand, is what you get after that data is processed. It becomes structured and actually means something, like an official exam result or your final net paycheck. Raw data has to be refined to become valuable information. Moving right along to Section 2, the data processing journey and handling massive volumes. Now that we know what data is, how do huge organizations handle absolute mountains of it every single day? It happens through a very specific step-by-step approach. Picture a school grading system, right? Step 1 is editing. You comb through and remove any errors from those raw test scores. Step 2 is coding, where you align that info into a specific system or category. Step 3 is data entry, physically typing it into the software. Then comes Step 4, validation. This is a crucial quality check to make sure no mistakes slipped through. And finally, Step 5, tabulation. That's producing the final, structured format, like printing out the actual report card. But wait, behind those 5 steps is this incredibly dynamic ecosystem of data handling. We're talking about recording, verifying, storing, and retrieving information constantly. Plus, all the dynamic manipulation, things like sorting, calculating, updating, and merging. This invisible, nonstop calculation is quite literally the heartbeat keeping modern offices functioning and allowing leaders to make fast decisions. Let's shift gears to Section 3, evolution of processing methods, focusing on historical methods. We're going to look at exactly how humanity has managed to do all this processing over time. This shift is honestly pretty staggering. Get this, the word computer actually used to refer to a person. Yeah, people used to just sit in rooms doing manual math all day long with pens and pencils. And as you can guess, it was painfully slow and human error was pretty much a guarantee. Then we moved into the mechanical era. Typewriters and early adding machines definitely sped things up, but they were loud and just couldn't handle really massive volumes of data. Today, we rely on the modern computer method. Driven by insanely powerful processors, it runs continuously with lightning speed and pinpoint accuracy. So why do computers so completely dominate today? It comes down to incredible speed and massive storage capacities. But the real game changer here is the undying reliability. Think about it. Unlike a human doing manual processing, a machine doesn't need a coffee break, it doesn't get tired, and it doesn't lose concentration. Add in automatic operation and the flexibility to run multiple programs at once, and you've got an absolute processing powerhouse. Which perfectly tees up Section 4, anatomy of a computer system, exploring it as a digital ecosystem. To understand how these machines are so reliable, we need to zoom out a bit. A functioning computer system is actually made up of 4 interconnected pillars. Now, we all know hardware and software, right? But it's the 3rd and 4th pillars that are surprisingly crucial. The human users, from expert engineers all the way to casual daily operators, are literally a component of the system. And check this out. The physical environment is too. Things like heavy-duty battery backups, ergonomic furniture, and even dedicated air conditioners. They are just as vital to keeping the whole ecosystem alive as the processor itself. Without them, the whole thing overheats and crashes. Finally, we've arrived at Section 5, the real-world impact, looking at the broader societal consequences. We've built the foundation, so now let's take an objective look at how this ecosystem actually affects us out in the real world. Looking at the big picture, it's a classic double-edged sword. On one hand, computers give us these absolutely life-changing conveniences. We have instant online banking, we save massive amounts of time, and we have free educational tools like Wikipedia and Khan Academy right at our fingertips. But simultaneously, this exact same tech creates some very severe real-world problems. We're looking at automation leading to job displacement, massive security risks from hacking, physical health injuries to our eyes and wrists, totally toxic electronic waste, and even rising social isolation. So all of this leaves us with one incredibly pivotal question to think about. As computers become exponentially faster and more automated, how exactly do we maximize all those amazing human benefits while minimizing the very real social and environmental costs? I'll leave you to chew on that as we continue to navigate this automated world. Thanks so much for joining me on this explainer, and I'll catch you next time.